Just got to show you today's office.
Quick, Twitter.
Oh, look at that, eh?
Make everyone at home jealous.
Look at that. I mean, this is where we're studying today. Fantastic.
Did you hear about the record on Alpine?
Yeah.
An hour 53. It usually takes an hour.
Morning. So here we are, Camp Arolla, July 2018. It's a fieldwork day, learning about alpine processes, and we're going up to measure soil respiration and other activities in relation to avalanche damage and altitude. So let's follow the team today, see what they get up to. There they are, loading up the back of the car. You can see the panorama of beautiful mountains around us. Hey guys, how you doing? Phil's making a little film today. Oh yeah. Collaboration of Lancaster and Lausanne students working together. Look at that, that's where we're going. Up there. Whoa.
Do you think we need it?
I'll stick it in just in case, because that tablet, it might mention it.
Yeah, it was being a bit sticky. Oh, it's in the bag. Yeah, it's all back.
So look at this, here is what I call an erratic. An erratic, look at that big boulder there. An erratic is a rock, which is a glacier, left here probably, well, a few thousand years ago. And there's the mountains of Arolla Valley around. Fantastic.
1, 2, 3 in the avalanche away from the edge. And that's allowing you to draw this figure that we showed yesterday, and your plots within sight are allowing you to have your error critical variance. Is that clear? Does that make sense?
Yes.
Cool.
And then you have
15, okay, that's good. So that's fine now, you shouldn't need to change that. This is the pumping of air before the chamber goes down, just to clean it out basically.
So it's another day. Here we are in the preparatory room, getting all the equipment ready. Good morning. Bonjour. Hello everybody, getting ready. There's Renata getting ready for going to work on the Glacier ice meltwater. Soils people getting ready for the respirator. Have we got those batteries charged? Have we got those batteries charged? All this charging going on here. Samples from yesterday. We really need a cool room. There we go.
Si vous voulez changer les paramètres pour la production des nuages de pointe,
I started the graph late, but it went up very rapidly.
Yeah, that's okay.
It's nice.
So we've come up here to 2,800 metres, 2,600 metres. It's high enough for us Brits who are not that acclimatised. You can definitely feel the difference in altitude. And we've got a team of students here who are learning about soil processes with altitude, and they've got a mobile erga, that's an infrared gas analyzer, to enable them to measure the carbon dioxide evolution from the soil, so the amount of carbon dioxide that's coming out of the soil. That's a measure of soil's respiration, soil breathing if you like. It's an index of the biological life and activity in the soil, and they're testing the hypothesis that this will vary through the altitudinal gradient. So they're starting here at 2,600 metres and then we're going down into the valley. And so it's fun. Everybody seems to be having a good time.
Hi, I'm Emily, and I'm here in the Swiss Alps in the Arolla Valley as part of a group of students from Lancaster University and the University of Lausanne. We're researching how elevation affects soil respiration. So down there we're measuring the soil respiration with an infrared gas analyzer. We're measuring the soil moisture and the temperature, and we've also been identifying the vegetation. We'll be heading down the valley, measuring at different intervals of 50 metres, and hopefully we'll be able to compare our results afterwards.
Look at this, lunch break. So this morning, going up to the glacier with the Glacier crew. Here's Dan. Dan's going to be my guide. He's doing his work from Lancaster on the glacier, and we're going up there. I mean, wow, that is so exciting. So, lead on, Dan. Off we go. Well, look at this. This is now, we're about 2,350 meters or so at the moment. What's this glacier called, Dan?
So this is the Glacier d'Arolla. It's the lower Arolla glacier, called that because there's also another glacier which we're traveling to, known as le Glacier d'Arolla.
Wonderful. Yeah, wonderful. Thanks, Dan. And just look at the moraines. As somebody that remembers doing, basic geomorphology and glacial geomorphology, you can see here the moraines, the glacial deposits actually in action. You can sort of imagine there is ice under here, being still melting under there. It's retreating. Wow, fantastic. So just look at this. We've just come over the col, about 2,600 metres or so now. We've just come into this glacial valley. Look at this. That's where we're going, basically. They're doing their research up there, I think, somewhere. We're going up there later on. Here's Mount Colon. Another mountain up to the right here. Apparently that's 3,800 up there. It's pretty high. Look at that big ice glacier there. Whoa, look at that. So here we have, I think, a fluvial outwash plain from the glacier. I remember learning about these in my undergraduate days, and here we are. The glacier's just around the corner, around here, and this is classic sands and gravels that have been washed out from the meltwater. Fantastic.
Hi everyone, so this is the proglacial forefield of the Glacier d'Arolla. You can quite clearly see evidence that the glacier was much larger here during the Little Ice Age. You can follow the path of the glacier around and you can see how high it was at the sides. there's quite a prominent lateral moraine to the left-hand side of the valley, and you can also see where there have been quarries carved into the rocks, and you can see there's kind of a small hanging valley there with maybe a little bit of ice in it, most likely dead ice now. I can't imagine that would be flowing anymore, but you can see the glacier has retreated massively up the valley since the Little Ice Age to its current position.
Cheers, Dan.
Okay, so another thing that's interesting about this area, you have a lot of these snowfields, which is just leftover snowmelt from the winter. But the most interesting thing about it is looking at the different debris cover. So for example, if Phil brings the camera here, you can see these kind of stones are embedded into the glacier, where they've absorbed the solar energy and transferred it through to the snow and caused the snow to be depressed, so they all end up sinking into the glacier.
So it causes melting, basically?
It causes an accelerated rate of melting, exactly. Whereas contrastingly, if you have these debris piles, they're much poorer at transferring the heat through. So if I just clean this off here, you can see how much this has influenced the melt rate, and it's caused a massively reduced rate of melting.
It's just ice there?
That is solid ice, yeah.
Wow, amazing.
And it's actually much colder than the surrounding snow.
Wow, thanks.
So that's that.
Thanks, Dan. So here we are at the base of the glacier. We've walked 3 miles, about 2 hours worth of walking up to 2,600 metres. And Renata is here, and the team are here. Renata, there she is. She's been measuring the meltwater that's coming out of the glacier and the water quality as well. And you can see we're literally having lunch with the glacier right behind us.
So we're doing the glacier hydrology project, and our aim is one is that to establish a stream variation of this river, and we use this instrument and probe to measuring the temperature, turbidity, and the stage of the river. Also, we take samples from the river every 30 minutes, and then we will need the snow melt measurement from the glacier and to work out how much the solar radiation will influence the stream.
Brilliant, thank you. Apparently the guy's saying that only 4 days ago that bit of the ice bridge collapsed in the glacier there, so you can almost feel things changing in front of us. There's the glacier covered in moraine, water running out of it. There's Emily, there's Dan the man. Dan, what's this glacier called again?
So this is the Haut Glacier d'Arolla, the upper glacier of Arolla.
Okay. So we're on the side of the glacier. There's this funky little bit of marking on the rock here. So what have we got here?
So here you can see the crust. It's one of the crusts we made. And we use this for the GPS position for the drone.
Oh, actually,
so we see this crust on the picture of the drone.
Oh, from above, from up there, basically.
Exactly.
Yeah, cool. Thank you. So we've just got to try and climb across the side of the glacier and get on the ice. Hey, I'm on the glacier. First time in my life, I think.
Welcome.
I'm walking on a glacier. Man. There goes Dan. Fantastic. Whoa. Awesome. Let's go look at the research. So this is amazing. I've never done this before. Walking on a glacier. This is the Haut Glacier d'Arolla. And here we are, the team, walking up the middle of the ice sheet. Apparently we've done all the risk assessments. Apparently it's safe. No crevasses of any threat. And how amazing is that, eh? Look at that. You got your videos on?
Okay.
So what's going on here then, Dan? We've got camera rolling here.
And all up here there's like big colonies as
So
well.
what are we looking at?
Whoa. They look like some species of Calembula. You can see up here as well, there's little puddled colonies.
And they're almost certainly Calembula. So these are very typical, you find them a lot in soil course, and they're quite important. I'm fascinated to know about them. I think we should definitely take a few samples back.
2,700 metres on the glacier in Switzerland. Yay!
Okay, so this is our experiment setup on the old Glacier d'Arolla. This setup's been running for about 5 days now, and what we're doing is we're investigating how debris cover influences melt rates on the glacier. So what we've got here is we have a setup of different thicknesses of sediments. So we have a base control just to see what kind of the norm is, and then we've got a light dusting of sediment, and it gradually increases up to a thickness of about 20 centimetres. And preliminary results, as you can see here, this light dusting of sediment has actually accelerated the melt rate compared to the control, and we've interpreted this as the sediment is so thin and the albedo is a lot lower than the glacier ice, so the heat from the sun can penetrate into this sediment layer and then be absorbed into the ice, and then thus accelerate the melt rate. Whereas contrastingly over here, where you've got a lot more sediment, it's unable to penetrate all the way through the ice, and it actually then has an insulating effect, meaning that it's similar to or even slightly reducing the melt rate.
Okay, so what does that mean? So in the wider context, what does that tell us, and what can we do with that information?
So in the wider context, we can then kind of look at natural moraines. So we can use kind of our analogues and our man-made setups, and we can look at natural moraines and then how that would, how kind of the...
Oh, and predict the ice melt.
We can essentially predict it using
I see.
systematic modelling.
I see. I see, I've got it. Well done, nice one. Fantastic. Hey. Look at this! Look at this! We've climbed the moraine to the top. There is the top of the glacier. We're on a medial moraine between two sides of the glacier here. There's Emily. There's Dan, there's Rob. Here's Phil infusing away. Look at that. Oh, this is like amazing. It's just amazing. There's a 360 for you. Just got to show you this. So look at the glacier there. There it is now. It's 2018. Here is a rock marked 2008. I can only presume this is where the glacier was in 2008. Look at that. Look at the retreat on that glacier. Must be 100, 150 meters. Amazing. Just amazing. Take a look here. All this water here. The ice sheets are melting. Yesterday the students measured 8 millimeters of movement of the glacier in just one day. The ice sheets are melting.